Our Earth sustained many dangerous hits throughout its past history. Ancient seas emptied, leaving fossils behind. Forests thrived, but oceans choked. 90% of species perished in the Great Dying. Dinosaurs emerged, but many bowed out. Dinosaurs vanished and mammals rose. Earth's past was just a dramatic film. Currently, we are preparing ourselves for a science fiction movie. Every movie will have a climax. Will our climax be a victorious one? Or tragic? There are so many factors that can be considered as threats to the future of the Earth. Upon narrowing down those factors, we identify 3 as being of paramount significance. Environmental disasters can be viewed from various perspectives, and they encompass the following key elements. 1. Climate alterations. 2. Ecological breakdown. 3. Asteroid collision. Climate change is an important factor that sculpts the Earth's future. Currently, it is a factor that affects the overall environmental well-being of the planet. Considering the future, climate change still plays a vital role. The primary driver of current climate change is human activity. Specifically, burning fossil fuels, such as coal, oil, and gas, releases greenhouse gases into Earth's atmosphere. These greenhouse gases trap heat from the sun's rays inside the atmosphere, causing Earth's average temperature to rise. Let's have a look at the impacts. Again, there are numerous factors to consider, yet the most significant and influential ones include unpredictable weather patterns, extreme weather events, melting ice sheets and glaciers, the global average temperature is expected to reach or exceed 1.5 degrees Celsius, about 3 degrees Fahrenheit within the next few decades. According to NOAA's 2023 annual climate report, the combined land and ocean temperature has increased at an average rate of 0.11 degrees Fahrenheit per decade since 1850, or about 2 degrees Fahrenheit in total. The rate of warming since 1982 is more than 3 times as fast, 0.36 degrees Fahrenheit per decade. If greenhouse gas levels continue to rise at present levels, Earth's global average temperature could rise an additional 4 degrees Celsius during the 21st century. With a 2 degrees Celsius temperature increase, heavy rain events are expected to become 1.7 times more likely and 14% more intense. Though these changes can't be felt in our daily lives, they showcase a potential threat to humankind if they remain unobserved and unaddressed. Firstly, let's delve into the definition. Ecological imbalance refers to the transformation of identity, loss of defining features, and replacement by a novel ecosystem. In simpler terms, it involves the rapid and irreversible disruption of an ecosystem's structure and function. When ecosystems collapse, they quickly lose their original structure and function. The collapse tends to homogenize and simplify the ecosystem. This means fewer species, habitats, and connections between them. The ongoing Holocene extinction is primarily caused by human impact on the environment. Deforestation threatens this massive, continuous ecosystem and biodiversity hotspot. Overfishing led to the collapse of this once thriving fishery. Up to 24% of marine ecosystems and 29% of global terrestrial ecosystems show symptoms of resilience loss. Approximately 87% of oceans and 77% of land surface have been altered by humanity. About 30% of global land area is degraded, leading to declining ecosystem resilience. It's clear we need to act now to save our resources for tomorrow's world. Asteroids are space debris left over from the formation of the solar system. They range in size from small pebbles to larger objects several hundred miles in diameter. Most asteroids reside in a concentrated region called the asteroid belt, located between Mars and Jupiter. However, some follow different paths, bringing them close to Earth. Fossil and geological records reveal numerous asteroid impacts throughout Earth's long history. Around 65 to 66 million years ago, a massive asteroid impact off the Yucatan Peninsula led to the extinction of dinosaurs at the end of the Cretaceous period. In 1908, a smaller asteroid exploded over Tunguska, Siberia, causing widespread devastation without direct impact. The most recent major asteroid impact occurred in 2013, when a house-sized asteroid exploded in the atmosphere over Chelyabinsk, Russia, damaging buildings in the vicinity. Significant climate change can result from the dust and debris thrown into the atmosphere by an impact. The Chicxulub impact caused a nuclear winter effect, disrupting photosynthesis and food webs. Asteroid impacts can lead to widespread species extinction events. The sudden disruption of ecosystems affects both flora and fauna. Depending on the size and location of impact, immediate damage includes shockwaves, tsunamis, and fires. Scientists actively monitor near-Earth asteroids using telescopes and radar. Early detection allows for potential mitigation. If an asteroid is on a collision course, deflection strategies include kinetic impactors, gravity tractors, or nuclear devices. NASA's Sentry system is a highly automated collision monitoring system that continually scans the most current asteroid catalog for possibilities of future impact with Earth over the next 100 years. The system detects potential impacts and analyzes them, publishing the results. Even though we get ready for surprise asteroids, we still wonder if we can really handle all types and sizes of them. Despite our efforts to gear up for upcoming environmental challenges, the dilemma remains. Can we fully harness our natural resources without causing damage? This uncertainty prompts us to reflect on whether we will ever master or fully grasp the complexities of nature. For the present, our aspiration is to avoid the devastation of our invaluable natural resources and to preserve them for the generations to come. We will meet you soon in our next content with more statistical studies.